we are going to discuss about the various gas laws. So basically here we are going to discuss about two gas laws and a generalized form. So the two gas laws are Boyles law, first one, and the Charles law, the second one. And then we will have a generalized gas equation. So we will start with Boyles law. What is this Boyles law? Boyles law is a experimental gas law which was given by Robert Boyle in year 6062. Robert Boyle in year 6062. This is an experimental gas law which actually explains about the variation of pressure and volume. So we will discuss about it in more detail. So let's see. It's a statement. It states that the volume of a specific mass of an ideal gas is inversely proportional to absolute pressure when the temperature is kept constant. So here two different conditions are there. First one is the mass is constant, which will always be constant for different processes, and here the inversely proportional to absolute pressure, and the second condition is the temperature is constant. So here T is constant and mass is constant. So we can write this equation mathematically as P is inversely proportional to V. So this can be rewritten as PV is equal to constant, some constant which is the proportionality constant. So this is the mathematical representation of this Boyle's law. Now if we see the graphical representation of this Boyle's law, and we will see the PV graph. So let a process starts from 1 here and continues and expands and reaches to point 2. So if you see, the volume increases, pressure decreases. So our mathematical equation P is inversely proportional to V, that is pressure decreases then volume increases. So it is starting from 1 and reaching here 2, and it is basically a rectangular hyperbola. So the nature of the graph is rectangular hyperbola. So it shows the variation of the pressure and the volume. So this was about Boyle's law. Now we will discuss about Charles' law. It was given by A.C. Charles in year 1878. So it determines the variation of volume and temperature. So we will see more about it in detail. So let's start with the statement. So it states that volume of a specific mass of an ideal gas is directly proportional to its absolute temperature. This is directly proportional to its absolute temperature when pressure is kept constant. Now if we will see that here the specific mass is constant here as it was in the Boyle's law, and the pressure is kept constant, that is pressure P is constant. So this can be mathematically, and it is directly proportional to absolute temperature, that is volume is directly proportional to absolute temperature. So this is the mathematical statement of Charles' law. So we can write it as V by T is equal to constant. This constant is proportionality constant. Right. Now how we will represent this on graph? Let's see it. So here again it is a PV graph, P versus V graph, and our process starts from point 1 and it moves to point 2. Here the pressure is directly proportional to the volume is directly proportional to temperature, and the pressure is kept constant. So this pressure is kept constant here. Volume increases, but this pressure is kept constant. Here, since the volume is increasing, so temperature will also increase. Right. So this was the representation of the Charles' law. We can more easily represent it as, suppose if we represent it on P versus, we can represent this as V versus T graph also. Now this will be a straight line. So, but basically we explained this with the P and V versus graph, right? So this was about Charles' law. Now we will discuss about general gas equation. We have discussed about Boyles law and Charles' law. So we will discuss about now general gas equation. Boyles, that is general gas equation, means it will follow both Charles' law and Boyles law, right? So we will see it with graphical and with mathematical. Now suppose some process starts from point 1 and reaches to point 2 where it follows the Boyles law. Here it is following the Boyles law, that is PV is equal to constant, and here temperature is kept constant. So this is the condition for the Boyles law. And from 2 to 3 it follows Charles' law. So here volume pressure is kept constant and volume is directly proportional to absolute temperature as a condition for the Charles' law. Now for process 1 to 2, from 1 to 2, if you see that P1 V1 is equal to P2 V2, right, as the Charles' law stated, and here the T1 is equal to T2. So let this equation A and this equation as B. Now from 2 to 3 it follows Charles' law. So V1 by T1 is equal to V2 by T2, and here V2 by T2 is equal to V3 by T3, right? And here P2 is equal to P3. Let this equation be C and this equation be D here. Okay, so from A and D we can see that P1 V1 is equal to P2 V2, but we can replace this P2 with this P3 because these two are equal here. So P3 V2, and let this equation be E here. Now from B and C, this was from A and D. Now from B and C, this B and C we can write it as V2 by T2 is equal to V3 by T3. So this from B and C we can write this equation, rewrite this equation as V2 by T1 is equal to V3 by T3, right? T3. Now this V2 is equal to here V3 by T3 into T1, right? Now let this equation be as F. So from E and F, that is P1 V1 is equal to P3 V2. So we can replace this V2 with this V2. So P1 V1 is equal to P3 into V3 by T3 into T1. So if you bring this T1 here, so we can rewrite it as P1 V1 by T1 is equal to P3 V3 by T3, right? So this is the generalized gas equation here. That is, if you rewrite this equation as PV by T is equal to constant. So this is the generalized gas equation which follows both the Boyles law and Charles' law. Thank you.